The Vega line of products primarily allows you to keep your legacy analog, T1, E1 PRI, or BRI infrastructure and connect to VoIP services such as a PBX or to the public switch telephone network directly. There are, however, many other use cases for these products, and we're going to cover all of these to give you a good understanding of where Vega gateways fit into a new or existing infrastructure. The primary and most common use case for Vega gateways is PSTN trunking, meaning that they are used to terminate analog or digital lines, convert those lines to voice over IP, and then connect using SIP trunking to a local or remote PBX phone system such as Sangoma's PBExact or FreePBX. There are PSTN trunking solutions for analog POTS lines, T1s, E1s, PRIs, and BRI lines. So let's say, for instance, you have a single PRI line plugged into an aging PBX system and you would like to switch to a voice over IP PBX, either hosted or on premises. In this case, you would want to use something like a Sangoma Vega 100G to terminate the single PRI line and then use SIP trunking to connect over to your PBX. You can also use Vega gateways with FXS connectivity to support analog devices and convert them to SIP extensions for your VoIP-based PBX. A good example of using FXS connectivity is retrofitting a building's existing infrastructure to work with VoIP. Let's take the example of a retirement home. Say there are 50 rooms in the retirement home and they decided to replace their old legacy PBX with a newer voice over IP system. In the phone closet, there are 66 blocks that run out to each of the rooms and then terminate to RJ11 jacks on the wall. The residents have analog phones plugged into the RJ11 jacks, and that's how they get their dial tone. Now, rather than having to rewire the entire building with Cat5e or Cat6 cabling to support voice over IP phones, you can simply implement a Vega gateway. In this case, it would be a Vega 3000G or a Vega 3050G. The Amphenol cables that come off the 66 blocks plug directly into the back of the Vega gateway and then convert each of the 50 RJ11 jacks in the resident rooms to SIP extensions on the PBX. This is transparent to the residents and allows them to continue to use their existing phones for sending and receiving calls. Similarly, you can use Vega gateways to trunk together a legacy PBX with a VoIP PBX, or even multiple legacy PBX systems. So imagine a scenario where you have multiple legacy PBX systems and you want to enable extension-to-extension dialing between them. You could use Vega 100Gs to interface with each PBX through a PRI or T1 interface, and then use SIP trunking to connect these systems together over a LAN, a private network such as MPLS or VPN, or even directly through the WAN. Now, this would allow you to greatly increase the functionality and efficiency of your organization without having to completely replace your phone systems. Next, let's talk about T1 E1 PRI Failover. So the device to use for T1 E1 PRI Failover is the Vega 400G because it includes bypass ports. Now, these bypass ports allow for a number of redundant configurations, and they function as a pass-through if the 400G ever loses power or goes offline for any reason. So here we can see in this example, the main Vega unit has failed, like this here, and the internal relay trips and then passes all traffic through to a secondary 400G. Next, let's take a look at an example of some PRI and PSTN redundancy. Now, in this example, we're doing trunking from a legacy PBX over to our voice over IP system. However, in the event of a failure, we also have a separate PRI line connected directly to the PSTN. This not only gives you a ton of connectivity options, but also provides excellent redundancy. The legacy PBX can be configured to use direct PRI connection to the PSTN all the time, or only in the event that the VoIP server is unavailable. You can also have the VoIP server use the PRI at this location if, for instance, its normal SIP trunk is unavailable. Next, let's talk about Enhanced Network Proxy, or ENP. So, ENP is a way to provide survivability to remote offices. Let's say, for instance, you have a satellite office with 2 POTS lines and a small handful of phones. Well, the phones themselves register to the Vega gateway. It functions as a SIP proxy for those registrations and then passes them on to the voice over IP phone system. Separately, the Vega is also terminating the POTS lines, which can be used by the remote IP PBX, or they can simply be backup lines. In the event that the internet connection to either location fails, EMP is smart enough to reroute inbound calls to a designated group of SIP phones, and it can also redirect all outbound calls to the local POTS lines. So there is an overview of the various use cases for the Sangoma Vega gateways. As you can see, these devices are very flexible and provide a ton of different infrastructure options, ranging from simple PSTN connectivity all the way up to remote office survivability. So I hope you enjoyed this video, and we will see you in the next one.